What's going on, everybody? It's O-Rock here, and I'm back at you with yet another video from MINGTECH Media. And in today's video, we're going to discuss the problem LeetCode number 340, longest substring with at most k distinct characters. Now, for this problem, you could go with a hash table and a sliding window two-pointer approach. That's one of the solutions, and I'm going to show you how to code up that solution. But first, I'm going to go into Sketch and show you a mental model and just create a mental model for you so you can see how I'm thinking of this problem, and I'm seeing like an avenue where I can use one of the building blocks of coding, which is a sliding window and a hash table, a data structure, to solve this problem. This is a medium level problem, but I'm going to break it down for you. It's also a premium problem, so I don't think you can access it unless you've got the premium version of LeetCode. But we're going to go through it together, whether you've got it or not. I'm going to show you how to solve it, or one of the solutions for it. But without further ado, let's jump into LeetCode, and then let's jump into Sketch, get some examples going, and then write the code. All right, guys, we're back here in LeetCode, and it says given a string s and an integer k, returning length of the longest substring of s that contains at most k distinct characters. Now, looking at the problem here, we see that we have a string up here for the first example that has ECEBA. And the first three characters would be the longest substring, and that's because in that substring you notice there's an E and there's a C. Those are two distinct characters, but they're like in a repeating sequence in that little substring of three characters, because you have another E after the C, which isn't a distinct character from the first E. So that's why that makes sense. And there's no other set of characters here in this string that sort of is longer than the ECE that we have here for this example. So that's why that answer is 3, right? Going down to the second example, we see we have two A's there and one distinct character. So the length of this whole string is 2, right? And we also see that the answer is 2. And the reason that is because when you have substrings, right, the full length of the string does count as a valid substring. So in this string, we only have one character that's repeated multiple times, or repeated twice here. And even if you had a character, or even if you had a string that had like 6 characters in it and they were all the same character, then for this particular problem, the answer would be the full length of the string, because that is a valid substring and there's only one distinct character. So you would just be going through the hash map and just adding the same value, or adding values to the same key. So yeah, I'm gonna actually go into Sketch and then just create a mental model, like I said, for how to solve this problem. All right, guys, so we're back in Sketch, and as you can see, I've made 2 different examples in the one on LeetCode. And our first example, our string is BCADEEDI, and then our k is equal to 2 distinct characters. And then for our second example, the string is AFZEFFEJ, and then our k is equals to 3. Now for our first example, with 2 distinct characters, if you look through it and you go through it, you'll see that this DEED is the longest substring with 2 distinct characters. And for our 2 here, our longest substring with 3 distinct characters is going to be the ZEFFE, right? Oh, sorry, FZ, from FZEFFE right here. So you have F, that's one character, Z, that's another character, E, that's another character. That's 3 distinct characters, and the longest substring here is from this F to this E here. Now I'm going to write out like a basic pseudocode or basic intuition solution, and then I'm going to walk through that in detail. All right, guys, so I've written out a rough overview of how the solution is going to work, and I'm just going to read through it real quick. So the first thing we want to do is we want to define our base cases, and our base case is just going to be if the string length is equal to 0 or k is equal to 0, we can just return 0. Then we're going to have to create our pointers. We're going to have 2 pointers. We're going to have a left pointer and we're going to have a right pointer. And the left pointer and the right pointer are going to be initially set to 0. Left is equal to 0. Right is equals to 0 as well. And then we're going to have an empty map that we create. So just a map, and that's empty. And then we're going to have like a max length variable, and that's going to be equals to 0 as well. And then from there, what we're going to do as we iterate from 0 to the length of the string, what we want to do is we want to find the substring with k distinct characters. And what we're going to do is we're going to use this max length variable and the conditions that we're going to check for the sliding window to extend it and contract it. We're going to check to see what the max length and the max distance that we find between any substring that we find that has k distinct characters. We want to find the length of that substring as we're iterating. So if it's greater than the max length, we're going to just update it. And then once we go beyond the bounds of the characters in the string, what we're going to do is we're just going to return the maximum length, right? So to explain that intuition a little bit more, just think of it like this. While we're doing this, we add the distinct characters to the map, or subtract. We subtract those characters depending on whether we meet our condition or not. And afterwards, using the MaxSum variable, we check to see if that's the maximum length that we've encountered so far for the specified k amount of characters, right? So every k character needs an entry in the map. So therefore, your map can't be greater than the size of k, right? So the right pointer keeps moving forward as long as the map is not greater than k. And it can be equal to k, but it can't be greater than k. Hence the title at most in the question. It's at most, and that just means you have to use like a less than or equals to when you're iterating, or like when you're defining your conditions. So when the map is greater than k, what we want to do is we want to reduce the values in the map or just remove them entirely. And that's that contracting that we're going to do from the left side with the L, right? So for every iteration, what we're going to do is we're just going to calculate the distance between the L and the R pointer and check to see if the max that we've seen so far is greater than like the last max that we calculated in the previous iteration. And finally, when we break out of this of the loop, when we go past I, we're just going to return the last max length that we calculated, right? So let's just walk through that really quick. So we have an L here and an R here, and they're going to start right here at that B, right? So we're going to move the R forward, right? So that's what we first going to do is we're going to add this B to the map. So let's just see map, right? We're going to add the B to the map, and then we're going to give it a value of 1. And then we're going to go to C, and then we're going to see that's the value of 1, 2. We've only seen 1 C so far, right? And then we're going to keep going, and then we're going to hit this A, right? We're going to hit that A, and then we're going to break the condition of that we set, which is that the map size can't be greater than, the k distinct characters, right? So we're going to add this to the map, right? But after we add it to the map and then, update the value for A, we're going to contract this window by moving L forward and just deleting or just removing, updating or whatever, the B. So now you're left with this substring, and we're also keeping track of the length as well. So the maximum length that we've seen so far is 2, right? So we're going to keep going from the right with the R pointer to this D again. We break our condition. We just add that to the map. We break our condition, so we contract from the left-hand side, and we just eliminate that. And again, this substring with this D, this A and D, that's going to be 2, so we don't need to update our max length. We're going to go again to the right, and then we're going to see E. We're going to add E in there, and E is it's the first one we've seen, so it's only going to be 1 value in the map. But it also breaks our condition, so we have to contract from the left. We have to take that A out, right? And then we're going to keep going. We're just going to update the E again. It's 2 values, and we're going to update now that we've done that. We're going to see that our max length for a substring with k distinct characters is from this D to the current E that we're at right now. And then we're going to just update the length to 3, right? Because it's greater than this 2, which we were finding before. And then we go to the right again. And then we see another D. We should just update that to 2. And then the max length we update to 4. And we go to I. So I, we add to the map, and this actually breaks our condition, right? So that's 1. It breaks our condition. So we just take this D out from that. And then we keep going. We're going to keep on taking the D out again. And we're going to go until we only have 2 characters in the map, right? So right now we have the I, and then we have, we're just going to keep on, we're going to reduce the value, sorry. Because we can either delete the character altogether. Let me just go back. We can either delete the character altogether, or we can just decrement the value. So we're going to just decrement because we're contracting. So we're going forward. So there's 1 less D there. So that's 1. Still breaks the condition. So we go forward again. We subtract the E. So that's 1. Going forward again. And this is the L coming in to contract from the left. I'm sorry, this is kind of messy, but I hope you're understanding this. And then we get to the D here, right? So it satisfies the condition of having 2 distinct characters with that DI, but it doesn't matter because our greatest length that we found was 4, and that's with that DED in the middle. Okay, so I hope this makes sense. That was kind of long. I'm trying to make this brief. I'm not going to go through the second example because I feel like that's a lot of explaining, and I really want to keep these videos concise. So I'm going to jump over to LeetCode, and I'm going to explain a little bit more as I code along. But let's get into it. All right, guys. So we're back in LeetCode. I really hope you guys can see my screen, and we're going to start coding. So we're going to just, just get into it right away. So the first thing we're going to do, like I said, is we're going to iron out those base cases that I was talking about. So we're going to say if s.length is s.length, that's a string, so we're gonna need to include that, if that's equals to 0, what we want to do, or if k is equals to 0, what we want to do is just return 0. Great. Now that we've got that out of the way, what we want to do is, like I said, define our right, which is equals to 0, and our left is equals to 0. And then we want to have that MaxSum variable, and we're going to set that equals to 0. And then what we want to do is we want to create our hash map. So we're going to have a hash map, and then it's going to be a character with a capital C. It's going to be a character, and it's going to be an integer for the values, right? I'm going to say that this name is map, and then we're going to say that's equals to new hash map, right? That looks good. And then after that, what we want to do is we're going to have a while loop that's going to iterate from the start R0 to the length of the string, less than the length of the string. So what we're going to do is we're going to say while right is less than s.length. What we want to do is we want to break into this while loop, and we're going to have a char that's equals to a, and that char is going to be char at and char at right. Remember, we're just adding every single character to the map and contracting and expanding it based on the conditions that we meet. So next thing we're going to do is we're going to say map.put, right? And we're going to have a for our char that we're putting, and then we're going to have map.get a default, and that's going to be our char A, and then 0, and then +1. I'm going to explain this really quick because I know it can be confusing if you've seen this just for the first time. So what this line of code really means is that so when you use the put method, it updates the values, right? You give it your key and then the value, and it updates it, right, accordingly, right? So what this method here, get or default, does is it's going to get the value for A, right? And if no value is existing in that for that key, we're gonna just set it to 0 or whatever you want. It doesn't have to be 0, but in our case, we're gonna have 0, and we're gonna add 1 to it, right? So if it doesn't exist, what's gonna happen is that value is gonna be 0, and then we're just gonna add 1. So this gets executed first. It goes in and search for the A, and if it exists, we just, it returns the value for that and then adds 1 to it after that. So that's how that works, right? So we're going to also have a condition for when the hash map is greater than K, right? So we're just going to come down here and we're going to do another while loop. Hold on. While we're going to do while the map dot size is greater than K. So we're gonna have those parentheses greater than K, right? So what we want to do in there is, this is where we're going to contract. We're gonna take the char from the left. So basically what we're gonna do is we're gonna say char B, because we use A, so I gotta use B. B is equals to s dot char at, and that's going to be left, right? So now that we've got that in there, we're gonna say if the map dot get, and then we're gonna say B, that character we just got. If that is equals to 1, what we want to do is we're just going to remove it. We're going to map dot remove that B, right? And else, let me see where that bracket ends. Else, what we want to do is we're going to say map dot put put B, and then map dot get B. We're going to get the B, and then we're going to subtract 1. So basically that's just updating the value if it's not 1. We're just decrementing it, right? So that's where that whole either remove it altogether or just decrement it comes from, right? And then after that, we're just going to do left plus plus to move the left forward, right? And then we're going to take this MaxSum variable, right? We're going to take this MaxSum variable, and where does this need to be scoped? Outside here is equals to, we're going to do math dot max, and then it's going to be the MaxSum between the MaxSum and right minus left plus 1. And remember, I was talking about in the explanation that since everything is 0 based in programming, we can't just do right minus left. All right, so let's just say you had a string and then you're at position, your right is at position 4 and your left is at position 0, right? We all know, since things are 0 indexed in programming, that that is going to be 4 minus 0 is going to be 4 in, like, regular math, but programming math, that's like 5 characters, so that length is going to be wrong if you don't add that plus 1, right? Because 0 through 4 in programming is going to be 5 characters, because we count to 0. So yeah, that's how that works. And then after that, we do right plus plus, right plus plus, and after that we just want to return MaxSum, I believe. Return Sorry I like for all that noise outside. I live in New York. It's a Friday and, you know, people are out and whatnot. But yeah, we return MaxSum. So I'm going to go ahead and try and run this. Why is run this? All right, cool. Everything is accepted. Let me use example test cases. Let me actually use a test case from my code, from like what I explained earlier, if I could remember it, or just make something up. SDFEER. Oh, okay. Run code. Great. Okay, everything seems to be running fine. I'm gonna go ahead and try and submit this. Good, great. So it's 11 milliseconds faster than 64% of the solutions out there. So that's pretty good. It's pretty efficient. And the time complexity for this is just going to be of O of n, both space and complexity, because what you're doing is you got to iterate through the whole length of the string, right? So that's O of n work. And then it's also O of n space, because as you're iterating, you're also adding to the hash map, right? You're adding and you're decrementing it as well when you're taking values away from the beginning of the map to contract the map and expanding the map. So that's O of n, and you're doing that as dependent on your condition. So yeah, it's O of n for space and time complexity. But yeah, that's it for this video. So if this helps you out and you like this type of content, I make a lot of content like this, go ahead and hit that like button, hit that subscribe button, and hit that bell notification so you'll be notified when I do make content like this. And to you watching this video whenever and wherever you are, I hope you have a blessed day and enjoy your weekend, your weekday, whatever time it is. Take care.